Hello, everyone. In this presentation, we will talk about how we have improved our repeatable vehicle design from scenario weeks 1.
Since the design brief changed, we made a lot of modifications in our CAD model. These include reducing the mass, reducing the frontal area, removing the battery holder, changing the springs, as well as their support system, which I'm going to talk about in the next slide. Next, please. When choosing our spring, we're calculating the spring constant first, based on the distance we want the spring to compress, which is about 4 millimeters, as well as known values such as vehicle's mass and velocity. The subsequent improvement in the design was a 0.8 gram reduction in mass, an optimal spring stiffness, and a more precise specification, including a Fusion 360 model. We also introduced a spring support system, which keeps springs parallel to ground when the vehicle is moving towards the wall. Finally, the spring is closed and flat at the ends, which ensures that the vehicle doesn't go in any direction after having hit the wall.
We decided to run an air simulation to show that our modified model has improved from the initial model. So to do this, we have to create a simplified model which neglected the motors and the circuits because that does not affect airstream. And we noticed from Fusion that the modified model resulted in a 27% reduction in chassis mass and 20.6% reduction in frontal area. And later we decided to use PLA material instead of pine wood board, which resulted in an impressive 78.6% reduction, resulting in 66% total mass of the chassis. And also we noticed that there is a negligible shift in center of mass after we have punched holes in our chassis, which is a good news. This is the result of the air simulation when the vehicle is running at a theoretical maximum speed of 0.2 meters per second. And we can see that in our final model, there is much less disturbance in the velocity field of the air. And we can also use a particle trace visualization, which shows that the airstream is much more stable in the final model. And we can also notice that the airstream of air particles, when making contact with the front wheel, is much more stable and less disturbed in the final model.
So in order to evaluate the outcome from the black box simulation, our team decided to run a hand calculation beforehand. Compared to the hand calculation did in scenario week 1, we still kept using an iterative approach, but this time including rotational drag as well as air resistance into the scope. After including all these resistances, our hand calculation yields very close terminal velocity compared to the simulation. In order to calculate the energy being used throughout the trial, we divided the whole journey into 4 parts, which are acceleration, cruise, impact, and deceleration. I would love to go into detail for my calculation during the Q&A session, but here I just want to demonstrate our final hand calculated result for the energy is 1.08 joules, which is very close to simulated figure of 0.98 joules.
Moving on, the cost of our vehicle the total cost of our vehicle was £24.86. We managed to stay within our budget by changing the material of our chassis from plywood to 20% PLA filament. Cutting our chassis costs by 59%, as using plywood would have cost us £3.50, while using 20% PLA cost only £1.45. 100% filament was not used as it would have been too expensive, costing us £5.30. Moreover, below you can see the structure of a 3D printed toilet handle using a 20% filament, which shows that the structure is relatively dense and thus a 20% filament chassis will be sufficiently strong to house all our components. Before assembling the vehicle, some components must be machined. Firstly, a 1 meter aluminium round bar will have to be cut into 6 145mm length bars, as they will be used as shafts to hold our pulley system. A CNC lathe turning machine will be used to accurately cut the aluminium bar into our desired lengths. Additionally, the pulleys, wheels, and chassis are all to be 3D printed using a Creality 3D printer. The illustration below shows the final assembly of our vehicle. Thank you for listening.